Righto, Year 11. I'm going to go over conditional probability again because I know that some of you had trouble with it, and even though the solutions that we did in class are going to be on the board, I'm going to do them again. And I'm going to go right back to the beginning for everything. So if you've missed some of the lessons or you didn't quite get it, you should be right after you have a go at these. So, conditional probability. And we've got the definition here. And that's just the probability of A given that B has already happened. The probability of A given the condition B. And we write that probability of A given B. Now we've got a formula there, but first we're just going to go up here and we're going to have a look at this history geography question to sort of get an idea and a feel for it, and realise that there are two-way tables and Venn diagrams that you can use. So we'll go up here to this history geography question. And the history geography question says, in a class of 30 students, they either study, and all of them do either, history or geography. 18 only do geography and 8 do both. So we set up the tree diagram, the Venn diagram, and you can see it's already done here. We've got 18 in geography, 8 doing both. This number here, this 4, comes from 30 minus 18 minus 8, because that's what's left, because there were 30 students originally. So, the question asks, find the probability that a student does geography given the student does history. Well, we don't need that 4 because we're just looking at this circle, because we're told that the condition is that the kid, the student, already does geography. Sorry, wrong way around, looking at the wrong circle, given that the student does history. So we're just looking at that circle. Now, how many students do history? Well, 12. So it's out of 12. And what's the probability that a student does geography from that group of 12? Well, there's 8. It's pretty obvious. The probability that they do geography given that the student's coming from history. 8 on 12. It's obvious, really. But I now want to illustrate that using the formula. So if we go down here, the formula says the probability of A given B is the probability of A and B, that's the intersection, over the probability of B. So let's go back and do that one using the the formula. So, or the probability of G given H. Well, that's the probability of G and H over the probability of H. Well, let's see what happens. Well, the chance of getting history and geography, well, that's 8, and there are 30, 8 over 30. And then, probably a student doing history is 12 over 30. There are 12 students who do history. And when we have a fraction, we multiply by the reciprocal, so 8 over 30 times 30 over 12, which gives us, the 30s will cancel, 8 over 12. So now you can see how the formula works. The other option, other than a Venn diagram, is also a two-way table. So let's have a look at this table. This table shows, and you can do a two-way table or a Venn diagram, they're the same thing. These totals here and these totals here, well, these totals are gained by going this way, and these totals are gained by going down this way. And both columns, or both of those two totals, should add up to this number here. All right. Find the probability, let's have a look at these. Find the probability that you choose a person that they're not vaccinated. Well, we can just look at the totals. There are 197 not vaccinated, and there's a total of that many students. So the answer to A, the probability of not vaccinated is 197 over 437. Now, let's have a look at the conditional ones. Infected, given that the person is vaccinated. Well, that means we're just dealing with this one here. Infected, given that they're vaccinated. So B, infected, given that they're vaccinated. Okay, well, it's going to be over 240 because there are 240 people who have been vaccinated. And the chance that they'll be infected, well, it's 13. Okay, now we could have done it, excuse me, the other way around. We could have done the people that are infected and vaccinated over the total, and the probability vaccinated, and we'd just be eliminating that 437. It'd be underneath both fractions, and when we multiply, you'd end up getting the same thing. Let's try the next one. Not infected, given that it is not, they're not vaccinated. Well, then we're just talking about this column. So C, not infected, given that they're not vaccinated. Well, not infected, that's 38, and we've got 197. There, we're right there. Let's look at the next one. Vaccinated, given the person is infected. So now we're dealing with this row. Because so D, probability that they're vaccinated, given that they're infected. Well, it's going to be over 172. And how many are vaccinated? 13. And there we go. So when you've got a Venn diagram or a two-way array table, it's pretty easy, and you should be right with those. So let's have a look at some of the questions. Oh, sorry, before we go on, let's look here. This is when we have events that are independent. And when they're independent, it just means that the probability of A given B, well, when they're independent, the probability of B has no effect on A. So it's just the probability of A. And I'll give you an example. Imagine I'm tossing a coin, so I can get a head or a tail, and I'm rolling a die. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, what's the probability if I toss I get a 6 if I've got a head. Well, there's no effect. The probability of getting a 6, given that I get a head, well, it's just 1 in 6. It's just a probability of getting a 6. It has no effect. There is no intersection. Now, because of that, well, there is an intersection. The probability of an event and another event is just multiplying those events. It's like it's on a tree diagram and it's just a normal probability tree diagram. So if we had it here, we'd have head, tail, and we have our 6. 1, 2, 3, 4, 5, 6. And we just multiply the probabilities. And of course, there's a half there. So probability of a head and a 6 is 1 on 2 times 1 on 6, 1 on 12. All right. So there are some things here that you need to know though. If you are testing for, and we'll do this, if we're testing for independence, we'll use that. If the two probabilities multiplied and give you the same probability as the two things intersecting or having it, then they're independent. And the other thing to note up here, is that this is just an equation, and what you can have, if you manipulate the equation, I can just multiply that PB across. So I can go PB, the probability of B, times the probability of A given B equals the probability of A and B. Because it's just an equation. If I multiply that PB over to here, and that's that rule. All right, so let's do some questions from the exercise now. We'll do some easy ones and we'll do some hard ones, because they do get hard towards the end. Well, let's have a go at these. So we'll try question 3 first. Now, remember with question 3, we can, so here we go, question 3. Well, this is again an obvious one. 2 dice are rolled. I can quickly draw it up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. And while I'm doing this, I'm only doing this so I can show the sample space, and I think this is important that you need to be able to do this very quickly, because you'll probably get 2 dice in an exam. It's a common question, rolling 2 dice. But if you can do it otherwise, you don't need to draw it out. In fact, I don't need to draw this out to be able to do it. Find the probability of rolling a double 6, given the first one was the first dice was a 6. Well, these events are independent. So the probability of a 6, given the first one was a 6, is just the probability of a 6. a double 6. It's just the probability of a 6 on the same go. It's 1 on 6. If I've already got a 6, if I've rolled one die and I've already got a 6, the chance of me getting another 6 is 1 on 6. Now, I could do that using the formula, but it's just not going to be worthwhile. The second one, B, the probability of greater than 8, the sum, if the first one was a 6. Well, what's going to make it greater than 8? Well, if I get a 3, that'll 3 and 6 will be 9, a 4, a 5, or a 6. Oh, sorry, a total of 8, so it's greater than or equal to a 2, 3, 4, 5, or 6. So I can get a 2, that'll make it equal to 8. Oh, sorry, if the first one was a 3. Sorry about that. The first one was a 3. So what's going to make that? I need a 5 or a 6. So there are 2 things I can get and 6. So even though that's conditional probability, you're just using your normal probability talents to knock that one out. Let's now go to question 5. So we're shooting targets. A missile has a probability of 0.75 of hitting the target. And it has a probability of hitting 2 targets in a row. So the probability of target and a target is 0.65. Probability of hitting a target is 0.75. What is the probability the missile will hit the second target given that it has hit the first target? Probability that it will hit the second target given, I'm going to call it T2, T2, T1. Well, that's probability of target 2 union target 1 over the probability of hitting a target. Oh, so it's 0.65 over 0.75. I need to get my calculator out. And I get 0.86 repeater. 0.86 repeater. I'm just going to check the solutions for that one. And question 5, 0.86 repeater. So that was a nice easy one. Let's do another nice easy one. Let's do 6. Oh no. Let's do 7 because we can do that with the Venn diagram. All right, so we'll do 7 with the Venn diagram. So here's 7. I'm going to draw a Venn diagram. And I'm pretty sure I did this one in class, but we'll have a look anyway. And what have we got? We've got 10 friends all go out into the sun. They either put on sunscreen or a hat. 5 put on only sunscreen and 3 put on both. So let's make that sunscreen and a hat. So 5 do that, 3 do both. Now there are 10 and they've all done something, so that's got to be 2. 5, 3, 2. Find the probability that a friend put on sunscreen, also put on a hat. Well, again, we're just looking at the sunscreen bubble. So the probability of a hat given they've put on sunscreen. Well, 3 over 8, because we're only looking at the sunscreen bubble. We're only looking at that bubble, that circle there. And we'll just check. Question 7. Yep, 3 on 8. Let's now have a look at 7b. Put a hat on, but didn't put on sunscreen. Put a hat on. Give a friend who put on a hat, didn't put on sunscreen. So the probability, put a hat on and didn't put on sunscreen. Well, there's 2 over 5. So, but I'm going to write the conditional. So, they didn't put on sunscreen given that they're a hat. They're a hat wearer. Well, there are 5 hat wearers. And the chance they didn't put on sunscreen, well, only 2 of them did that. So that's 2. I'm just checking out 2 and 5. All right, so those sort of ones are pretty easy. Let's get to some harder ones. Let's go down here. We'll do question 11. So they've got the two-way table here. Now, find the probability that a person selected at random owns a smartphone. So they've got a smartphone, given that they're a tablet. So I'm just looking at that row. Well, that's pretty easy. 23 have a smartphone, and there are 31 people. Well, let's find the probability of the second part. Doesn't own it, given they owns a smartphone, given they don't own a tablet. So smartphone, and they don't own a tablet. Well, then I'm looking at the other one, no tablet. I'm looking at that one. Oh, that's 60. I've drawn over that now, so I can't say 65. And how many don't own a tablet? Out of 68. So we don't need to use a formula when we're doing some of these, but you could, right? And I'll do the last one doing it that way. B. Owns a tablet, given that they own a smartphone. Well, this time we're using that one. So it's owns a tablet, well, there are 23 of those, and the total is 88. Now the last one. Number 2. Owns a tablet, given that they don't own a smartphone. Now we can see that this is easy. It's that over that. But we'll do it using the formula and using the whole thing. So that's the probability of T and not a smartphone over the probability of not a smartphone. Well, how many people own a tablet and not a smartphone? That's 8. How many people are there altogether? 99. What's the probability that someone does not own a smartphone? Well, that's 11. How many people are there? 99. And when I multiply by the reciprocal, 8 on 99 times 99 on 11, the 99s will go, and I'll just be left with 8 on 11. So the formula works. So let's try one that has a formula when we have to use it. Righto. So question 15, it's the one we did in class, and it's quite hard. And I did 15 and 16 and 17. I'm going to do 15 and 16 here. You can have a go at 17. The solutions to 17 are on the web. And then I'll have a quick go at question 19. So 15. A tennis team has a probability of 76% of winning a match when they're at home and 46% of winning a match when they're away. If the team plays 58% of their matches away, find the probability that they win their match given that they're away. Okay, so let's have a go at A. Probability of winning given that they're away. Now, what you have to do is you have to draw a tree diagram. So they're either at home or away. They either win or they lose. They either win or they lose. Now the chance of them being at home, well, they play 58% away, so this one is 0.58, and this one is therefore 1 minus that, so 1.42. If they're home, the chance that they win is 0.78, I think, isn't it? 0.76. 0.76. So therefore, the chance that they lose is 1 minus that is 0.24. To win when they're home, winning a match at home, we just did that one. If they're winning a match, 45% winning a match when they're away. So 45 is 0.45. And here, this is 0.1 minus that, 0.55. So, probability of winning given that they're away. So, that's the probability of winning and away over the probability of away. Well, winning and away is this one. So that's 0.58 times 0.45. And the chance that they're away is just 0.58. Which is 0.45. Now, we didn't need to do it that way. We could have just said, oh, if they're away, chance of them winning, it says it in the question, is 45.45. But I wanted to show you how to do it using the tree diagram, because for the next ones, you do need the tree diagram. So let's go to the next question. Are at home, given that they win a match. Right, now this is a little bit trickier. Here are my two scenarios of winning. So I'm going to work out B. The probability that they are home given that they've won. Well, that's the probability that they're home and they win over the probability of winning. Now, probability of home and winning. Well, that's just this one. All right? So let's put that one in. 0.42 times 0.76. Now, to do the winning, we have to do all the things where they win. Those two. They're the two situations of winning. So 0.42 times 0.76, or, which is winning at home, or they win away, which is 0.58 times 0.45, which gives us 0.55. 55%. So C. Are away given they lose a match. So we want to find the probability that they're away given that they lose. So now we're going to be doing these two. Let's have a look at it. So the probability that they're away and they lose over the probability that they lose. And there are two situations where they lose. You have to look at the tree diagram for that. Well, that they're away and they lose 0.58 times 0.55. And the two scenarios are they are away and lose, or 0.58, 0.55, or they're at home and they lose, 0.42 times 0.24, which gives us 0.76 or 76%. So what do you do in these scenarios? When you get these, you're going to have to draw a tree diagram where you're going to have to work out the probability of each event happening so that you can find out this given condition, how that can occur. Let's go to question 16, and I'll leave 17 for you to do. So 16. Okay. So what do we got here? We got a factory producing solar batteries. Probability of new battery being defective is 3%. However, if the manager is on duty, the probability of new battery being defective changes to 2%. The manager is on duty only 39% of the time. Okay. Let's go. 16. Let's draw a tree diagram. Either the manager's on duty or the manager's not on duty. And what was the chance of that? Manager's on duty 39% of the time. So 0.39, the manager's there, which means 1 minus 0.39, this is 0.61. Now, the battery will either be defective or not defective. It'll be defective or not defective. Now, the chance of it being defective when the manager's on duty, that was 2%, 0.02, which means not defective is 0.98, 1 minus 0.02. If the manager's not on duty, it's 3%, 0.03, and that's going to be 0.97. So, what's our question? Find the probability that the manager is on duty if a new battery is defective. So, the probability that the manager's there given that it's defective. Okay, well, that's the probability that the manager and a defective battery. Whoops, I put defective. I don't need that, they're defective. Over the probability that the battery is defective. Well, the manager being there and the battery being defective is 0.39 times 0.02. Now, what's the chance the battery is defective? There are two situations. There's that one and that one. Now, one of them we just wrote, so manager's there and the battery's defective. Or, so we add, manager's not there, 0.61, times the battery being defective, 0.03. Which gives us 0.29885. And we got 29.9%, which is the same. So questions 15 and 16 are difficult. So is 17, but once you learn that methodology, you'll be all right. I just want to have a look at these ones. Question 19, 18 and 19 are very easy. And 20. I'm going to do 19. It's a really easy one. If P of L equals 0.7, and P of M, L and M is 0.0204, and P of M is 0.12. Show they're independent. Well, if they're independent, P of L and M should equal P of L times P of M. So, does 0.0204 equal 0.17 times 0.12? Well, right-hand side equals 0.17 times 0.12, which equals, so just grab my calculator, we know it's going to be 0.17 times 0.12, 0.0204. So the right-hand side equals the left-hand side, thus L and M are independent. They're pretty easy. So 20 is going to be the same. 18 is just a version of your P of A union B equals P of A given B equals P of A union B over P of B. And you're just going to write an equation. You're going to multiply the PB by the P of A given B. All right, so I hope that helped. I hope you have a better understanding of the conditional probability and how to use it. It is a new topic. You will definitely get tested on in your prelim exam and more than likely, highly likely that you'll get it in your HSC.